Okay, this is Walker. I'm the president of Intellic Integration. In this video, I'm going to go ahead and show a proof of concept that's come out of some beta testing with the EZLogix PLC. I did not write a script for this, which is what I normally do for videos, so forgive all the ums. I will probably post the results of this on our blog at blog.intellicintegration.com. So for this proof of concept, I am using a EZRack PLC, which I have set up here. So this is an EZRack we purchased from EZAutomation. EZAutomation was in the process of they already had an IIoT solution native into their PLCs, and we met with Vikram, who's the president of EZAutomation, and he told us that they were working on some firmware that would have been Sparkplug B compliant. I got an email from Vikram on Friday containing the new firmware. So I've been doing some testing. So I created a VM that to install the Beta Designer Pro, because it is a different copy of the software, as well as the updated firmware. There are some caveats to this firmware. So it is Sparkplug B compliant, which means that basically the JSON is constructed, the payload is constructed in a way where Cirrus Link's modules and Ignition can consume and generate the tags that are inside the PLC, which is one of the reasons going Sparkplug B is so important. Otherwise, you have to write a parser on the broker side where you're consuming the payloads. You got to write a parser to understand how to create your tags, so you can then build your screens. So this is Sparkplug B compliant. There's a couple things they're working on. They're working on storing forward. There is a tag limit right now, a topic limit, I think, of 96 topics, and I think they're going to expand that up into like 250. It's a function of speed. So, so right now, what I have is this PLC, which is running the updated firmware and a program that I wrote. I also have an Ignition instance running in the cloud, and these are talking via LAN. PLC is wired to the LAN here in the office, and then over the WAN to this server, which is running in Washington, I think. Actually, I'm not sure where it's running. Anyway, it's a cloud server. On Ignition, I have distributor, engine, and transmission running. And then all I've done is built a program. I built a program inside of the EZRack PLC, or the EZLogix PLC, to do some benchmarking. So real quick, this is super easy to set up. So the Sparkplug B, or the Sparkplug setup, is pretty straightforward. So the first thing you got to do is go into the Mqtt Setup and go ahead and put in the broker IP address, which I've done here. Excuse me. I'm going to mute real quick so I can cough. So I put in the broker IP address and then my username and password. And then what I do is I just created a project. So what I've done here is I want to benchmark the amount of data that's being transmitted from the PLC to Ignition, because we want to use these PLCs typically in serial networks, but so I want to go ahead and get a feel for how many topics can I publish before I start running into, say, 1K a second worth of bandwidth, right? So I essentially have 5 sections of code here, 1 through 5, and then I have a little, I have a maintenance logic here that basically allows me to start a motor, track the number of minutes that motor's running, and then once it hits a certain number of minutes, it tells me I need to do maintenance on that motor. I'm not going to turn this code on for the benchmarking, but that's what I've got here. So once I write my code, then all I do is go into the Sparkplug setup, go over to publish tags, and this is already done. And I'm part of this video. I'm going to show you. I'm going to add another section of logic and show you how this is all done. Then all I do is grab the topics, the tags that are inside the PLC that I want to publish as topics. So I've created this EZLogix group in the PLC1 node, and then all the topics that I want to publish. In this case, all of my topics are read-only with the exception of the input bits, which we're going to be toggling in order to start the group of each group. And then the presets for the timers are also read-write. In this case, I have the timers set pretty simple. So I have an input bit that closes an output, which once this output is closed, it starts all 4 timers in the group. One timer is set to change every 1 millisecond, and we go for 10,000 milliseconds, and then it'll just continue to run. The second is 1,000 milliseconds. The third is by the 100 milliseconds, and the fourth is by the second. We go for 10 seconds. And I actually didn't mean to do that. I meant to do that in 10 millisecond increments, but I'm not going to make any changes now. So what we're going to do is my benchmarking code is going to come in, and one at a time we're going to go ahead and turn on the group of timers, and then we're going to track the number of bytes that are sent over the wire, and then print what the payload was over a set amount of time per second. And then we'll go and start group 2, so it'll be no groups, then 1 group, then 2 group, then 3, all the way up to the 5 groups. Okay. All right. So I've already run this test. I ran it using a 60-second cycle. So this is the code that we're running. So my sample size was 60 seconds. We're going to change this to 10, and I'm going to show you and let you see it run. So essentially, what happens is we go through and we get the start time. We do a 10-second sleep. We read the total bytes received before the sleep, total bytes received after the sleep, and then we do some calculations in terms of, and we print the total bytes per second over that sample size, the total bits per second, assuming that it's 8 bits per byte, and then the total number of bytes transferred, and then our true sample time. Okay. So I've already run this test once using 60 seconds as our sample size. We're going to run it using 10 seconds here in a second. So with no topics running, with no topics publishing, so while the topics are there, right now you'll see that we have nothing running at all. What's going to happen is these inputs will get turned on, and our timers will start running, and we'll go ahead and monitor the. We're going to go ahead and monitor the payload, the number of bytes coming over the wire. So in this case, I'll go ahead and reset. And so we're just going to cycle all the way through. When I ran the first test with no groups, obviously it's 0 bytes. With just the first set of timers, first 4 timers, it's 239 bytes a second. With 8 timers, it's 356 bytes a second. With 12 timers, it's 415 bytes a second. With 16 timers, it's 449, and with 20 timers, it's 467. All said and told, that is 20 topics that are updating multiple times per second in order to achieve that much data over the wire. That's not typical. Generally, for every 100 OPC tags you have in an OPC server, only 7 of those change every 60 seconds. So this would assume that we have a bunch of high-speed transmission. I really want to push the limits and see, just how lightweight is the MQTT protocol. So a couple things I'm going to do. I'm going to go ahead and change my sample size to 10 seconds. So what we're going to do is for each group that we run, it's going to run for 10 seconds. And I'll just move this code over here so you can watch the. So what we're doing here is we're going to go ahead and turn on our code, and then it'll cycle through. We'll do our calculations, and then we'll turn all the bits off inside the PLC. And in fact, what I'll probably do, let me do this, is let me go ahead and go online with the PLC here. And we'll switch to monitor mode. And so we'll be able to watch these come on. Okay. So let me go ahead here. And again, all of this will be over MQTT. This will not be any OPC UA. In fact, there are no OPC connections right now. All right, so I'm going to go ahead and start my code. So it's going to run for 10 seconds, and it's going to go ahead and give us a baseline of 0 bytes, obviously, because there are no topics updating. So it gives us 0 bytes. Now what it's done is it's turned our first block of timers on, and it's doing our calculations. And if I come over here, and you'll see the timers have come on. All of this is over MQTT. So our first 10-second sample has been completed, and we saw about 216 bytes a second. With 2 groups running, it was 272. With 3 groups running, it is 364. With 4 groups running, it's 388. And with 5 groups running, it was 362. And then our code should go through and shut all these off. And if I go back over to our PLC, we'll see that all of our timers have been shut off. So I'm going to go ahead and take us out of, I'm going to switch to edit mode, and we're going to go offline, because now what I'm going to do is I'm going to go ahead and add another group of timers, and then we'll do it with another group of timers. So the highest payload that we saw was an average of 362 bytes a second running all the groups. Okay, so that's with a total of 60 topics, but 20 of those topics changing multiple times per second. That's off the timers. Okay. Okay. So right now you can see these are all the topics that we're publishing from the PLC, and we'll go ahead and we'll come over to our PLC, and I'm going to add another group of timers. So what I'm going to do is insert this in here. This is what I'll tell you. One thing that became pretty obvious for me. I've been doing a lot of work with MQTT over the last 1.5 to 2 years, and in a bunch of groups of companies have adopted. Most people have been very slow to adopt Sparkplug B, and I spent a ton of time trying to convince manufacturers to adopt it, but everyone's in a wait and see mode. I was super excited when I met Vikram to see that Vikram was as excited about Sparkplug B and MQTT as I am, because of the potential for our clients. So what I'm doing is I'm creating new inputs and outputs, and I'm going to go ahead and create timers 21 through 24. And you can go ahead and fast forward probably, I don't know, maybe 30 seconds if you want to not listen to me breathe. But what I can tell you is this: we're in beta. This is beta, and I have not run into a single issue, which just never happens. I mean, this has been the smoothest beta testing I've ever had in my entire career. So Vikram and your team, you did a great job. I've run into no issues. Okay, just go ahead and save this, and then all I'm going to do is go over to the Sparkplug. A couple things I need to add. So I need to add my input and my output, so I show them. So I'm going to grab these two. The cool thing is once you bring these over into a topic, into a group, they don't show up anymore. I'm going to change that to read-write. Very simple. And then I'm going to grab my last group of timers. So I'm grabbing the accumulate and the preset for each timer. And then all I do is just drop these in here, click OK. I'm going to go ahead and save, and then I'm going to transfer my updated code to the PLC. And all of that funky looking serial connection you saw up there was me. I wanted to see just how robust these things are. It's pretty impressive, actually, how robust these PLCs are. And at their price point, I mean, we're talking, I think this unit, we paid maybe $300 for it or something. I don't know exactly, but I know it was only a couple $100. Okay, so if I come back over here, these tags should have already, we should see an update here in a second as the PLC comes back online. There we go. So now it's published, and we've seen our input. So we're going to go ahead and run our test again. So now we have our other group of timers in there. Again, all that was done in real time. So we'll do this 10 seconds. The only other thing I'm going to do is I'm going to change my group size. So I had 5 groups, now I have 6. And then we'll go ahead and run the test again. Okay, and just like before, we'll come over here and we'll take the PLC online and we'll monitor. I'm really excited to test the store and forward, which we should have right after Thanksgiving. For those of you who are watching the video later than the day I publish it, today is Sunday, November 19th. Actually, I think the Cowboys are playing right now. This is how dedicated I am. I'm missing the Cowboys game. All right, I'm going to go ahead and run our test. And just like before, we're going to do it with a 10-second sample. So now we have 70 total topics. We're getting up to our limit. So you'll see our baseline was 0. We'll go ahead and bring this over here. So our first group is running now. So we saw 224 bytes a second again. We are at 334 with 2 groups. We are at 406 with 3 groups. And you'll notice the way the timers are all running right now. If I come over here, be able to see that they are all running. Okay. With 5 groups, we saw 481 bytes a second. 4 groups, we saw 435. And with the full 6 groups, we saw 430 bytes a second. Let's make sure. Yep. So these were running. And then what I'm going to do is I'm going to come in here and start that last group again. Just make sure everything looked right. Okay. All right. So that is my benchmarking test. So a couple of like quick pieces of feedback. You know, EZAutomation's done a phenomenal job. They were only working on this firmware less than a month. I didn't have any issues with it. No crashes. Install was easy. Building the program's easy. I've been playing with the PLC since September, so I'm super hyper impressed with what they've done. The fact that it's Sparkplug B, so that the tags all come in native with their data types, is impressive. I do have another client. I do have another MQTT client running. So this is an Intel compute stick that we're testing, and it's running Ignition Edge. So the Ignition Edge is also Sparkplug B. So I can change. So over here to the right of my computer right here, I've got another machine running. It's an Intel compute stick running Ignition Edge, and I only have a single topic being published. But our bench test was focused strictly on this node right here, So the data from the other edge device didn't have any impact on the results. So again, the overall bandwidth, the total amount of data transferred, even with 60 topics changing multiple times a second, is minuscule. 430 bytes a second. That's pure MQTT. So there are two more tests I have to run. The next test is pure OPC UA with no MQTT, and then the last test after that will be to run the MQTT benchmarking with Sparkplug B from the PLC. Will be to run that benchmarking over a cellular network, which I do have a cellular gateway. We'll be testing that into the cloud, and I'll be publishing those results as well. Again, I'm Walker Reynolds. I'm the president of Intellic Integration, and thanks for watching.